Ambient temperature and conductor heat contribute to insulation degradation. Okay, so you're talking. Not only do you have to take in the ambient temperature, okay, but whenever you push current through a conductor, you give off heat. Okay, this is most commonly found in factories, and then when you put them inside a conduit where you can't get rid of that heat, then it becomes even a bigger issue. Okay, houses. The only place that this would really be a problem would be your services. Okay, because that's about the only thing that's actually run in conduit in a residential setting, is a service or a feeder. Okay, but in an industry setting, almost everything is ran in conduit. Okay, because you don't want to get it hit or getting stepped on or getting cut or getting broken. Okay, so everything's ran in conduit. So this really comes into play here. So ambient temperature and conductor heat contribute. Okay, so you have to take into account ambient temperature. Okay, so what we got here, we got a boiler. We've got electrical panel. Here's our conduit. Anything that's on or around this boiler is going to be exposed to even higher temperatures. Okay, I know out of Camoplast when we were working on their injection mold, is very, very, very hot. Because they have to keep their molds about 350 degrees for Celsius. So you got that much heat from trying to keep those molds hot, and you got wires running next to them. That's when it really pays off to understand what type of conductor you're going to need. You guys need to remember that heat will lower your ampacity. And that's just the main thing. Heat will lower your ampacity. The weight of the conductor shall not be passed on to conductor terminations. So what they're saying here is don't hang stuff by the conductors. I mean, that should be common knowledge. And even what happens is you get a hoist, a control push button for a hoist. Okay, even that, you don't use the conductors to hold it up. You run a guy wire, a support cable with it. Because what happens is, alright, well tell me this, what happens if I start to pull out a conductor out of a terminal right? Connection gets bad. What's that do? What's that do to my circuit? Generates heat. Why? Why does it generate more heat?
It's forced to work harder.
Because it's forced to work harder. Why? Because there's more resistance. Okay? And eventually, if you do it, you'll end up pulling the wire out of the terminal, and then you have to call over a maintenance guy and say, hey, my push button station is not working. Like, well, yeah, you pulled the wires out. Proceed to that. Okay. Twist-on wire connectors are available for directly splicing aluminum to copper. Okay. Twist-on wire connectors. What do we call them?
Wire nuts.
Wire nuts. Okay. Simple. Wire nuts. All right. Whenever you connect copper, to aluminum, okay, you have to be careful, because copper and aluminum together with oxygen will cause oxide. Okay, what's another name for oxide? Rust. Right? They will actually corrode together. Okay, and then what's that corrosion do? Increases resistance, right? Which increases my heat. Which, if I increase my heat, what's that do to my conductor ampacity? Lowers it, right? That's how this guy burned up. Remember, I told you that my wires were rated for 70 amps. The most I was pulling was 50. I shouldn't have had a problem. But, because of this loose connection, it generated more heat. Now more heat, added in with the current, shortened the life of my wire. Overheated my wire, even though I should have been able to hold it. But it wasn't. Due to that extra heat. Okay. Some electrical installations specifically require that solid or stranded conductors be used. Okay. Stranded or solid. Which one is smaller in diameter? What? Solid is smaller. Right? Because if we look at this, here's our solid conductor, here's our stranded conductor. If they were both 12 gauge wire, this one would actually be bigger. because of these little air gaps right in here. Okay, there is new wire out because these stranded wires are circular. Okay, now there's new wires out. They're rectangular, so they can actually fit together tighter. Okay. I don't see it as that big of a deal. Anyone know what is the largest size solid wire you can get?
10 gauge?
8. Once you get above 8 gauge, then you go to stranded. Why would I go to stranded? Flexibility, right? I mean, if you're in the morning class, you know all about flexibility with our stranded wire. Just kind of flops everywhere. You know, our nice Romex, we can bend it, make it look real pretty. Then with that stranded, you try to make it look pretty and it just coils back up. Okay? That's the flexibility of it. So that's why, once you get above 8, it becomes stranded. And if you ever have to bend 8, it's a booger. It's tough. Okay?
When they get into bigger KC mill sizes, do they use the strands? I'm guessing they're just basically solid wires that are, you know, ran together and twisted. Do they use different gauges of the solid wire to make the stranding? Like,
yeah, you can.
Like, do they use 8 gauge solid wire inside of that to make the different strands, or do they use something like 14 gauge or?
No, it's going to be small. Well, it depends on the wire you get. This one looks like it's 14 gauge wire inside there. I know when I worked at the rock quarry, it was even finer. It's probably about 20 gauge wire. I mean, it was tiny. The only bad thing is when you go to, you know, strip it back and then you've got a bunch of hairs sticking out. And that makes it kind of a pain in the rear. You know, this one's about 14, but no, you can get them in smaller, and you know, I wouldn't guess you.
Now, will it say what size the stranding is on the sheathing? It won't.
It just tells you how big the overall size is. That would be something you'd have to work out with your supplier.
I guess.
Okay. Proper conductor identification helps ensure worker safety and maintain integrity of the electrical system. Okay. Start to talk about colors. There's a reason why the color system is set up. It's so that, you know, I install it, you know, Pat can go back and troubleshoot it because he knows that I use, you know, red is my power wire, white is my neutral, and green is my ground. He doesn't have to go back and double check everything that I've done. He knows that this is an ungrounded conductor, and this is a grounded, and that one is a ground. Okay? That's why we use a color system, for easy identification, for safety, and for faster troubleshooting. Okay? So that's why, you know, when we were pulling our wires through the conduit, you know, we were all using different colors. So that way, you know, if Zach's lab failed, we know that he's on the pink wire, so we can follow the pink wire easy. We know that that pink wire is the hot wire, and the white was the neutral, and the green was his ground. Okay? Just make that much easier. By the way, while I'm thinking of it, in DC, okay, don't let this confuse you, but it's just kind of neat. In DC wiring, there is no color codes. None at all. Okay, I've been out to industries. When I worked out at Camouflage, I opened up one of the panels, and there was a green wire running from a DC positive onto a photo eye. I was like, man, what the heck? You know, you as an electrician, you should never, ever, ever, ever use green for anything but a ground. DC, there is no codes for that, for conductor identification. So you should always stay vigilant with that. Never run a green, because that really threw me off. That did not make any sense.
Why do they not have a code for DC?
Because it's a low voltage situation. We're talking about, when we talk about rules, we're talking on rules on 50 volts or more, or greater. 50 volts and less, pretty much do whatever you want, because it's considered to be safe. Okay? So when you're talking about DC voltage, you know, you're talking about 12 volts, 24 volts.